Auzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so for subject MAT138, which is calculus for video group presentation assignment, our lecturer is teacher Mawardi bin Omar with code EC110 from class PEC1101 1D1 and D2. So for our group is group number 4. We decided to choose the title of Application of Integration. Before that, my name is Muhammad Saifuddin bin Zamzuri.
My name is Muhammad Alif bin Muhammad Yaziz.
And my name is Muhammad Afwan bin Basri.
Okay, so before that, before we proceed our presentation, do you want to know our member groups?
So my ID student number is 2020826778 and you can call me Alif.
And my ID number is 20208815 and 22. You can call me Ayin.
And my ID number is 2020808786 and you can call me Afwan.
Okay, so in this slide, for topic of application of integration, what will you see and learn? Firstly, we will say what is integration, why we should use integration, what to solve, how to solve, conclusion, and the last one is reference. So, firstly, what is integration? Integration is a technique of finding a function gx, the derivative of which dgx is equal to a given function, which is we commonly use as fx. This is indicated by the integral sign as you can see in the slide, or as in integral sign fx, usually called the indefinite integral of the function. So, why do we use integration? The function we use integration is finding the area under a curve. To find it exactly, we can divide the area into infinite rectangles of infinitely small width and sum their areas. It's a fundamental operation of calculus and serves as a tool to solve problems in mathematics and physics involving the area of an arbitrary shape, the length of a curve, and the volume of a solid, among others. So, what is the use of integration in our life and why it is important for us to learn integration in our life? Firstly, for example, in medical science, the function of integration is to calculate the rate of growth. Second, research analysis, they use integration to observe different process. And the last example is the function of integration, chemistry to determine the rate change of chemical reaction. So based on this slide, we can see how the importance of integration.
So what to solve? Area between two curves. So the question is, find the area of the shaded region. So first of all, as we can see, area for the formula of integration, area is equal to integrate a to b cs. Why it becomes cs? Because it depends on limit integral suitable of on x-axis or y-axis. So in the question, the limit integral is suitable on x-axis, so we use cs. If the limit integral is on the y-axis, then we use cy. And then first of all, how to calculate the cs? Cs is equal to function. So first function is fx minus gs, or we can call y top minus y bottom. So let's see how to solve it. So first, to find the error, we must to find CS. As I said, CS is equals to find Fs minus Gs, or we can call Y top minus Y bottom. In the question, as we can see, the first function that we see is y equals to x cubed plus 1, and then from bottom that we can find is one straight line that will be y equals to 0, and then we substitute the equation. So fx will become x cubed plus 1, and then gx will become 0, and then we minus it, and then we can get x cubed plus 1 to find cs. And then we integrate it. Error equals to integrate a to b cs ds. So we substitute it. Integrate. So our limit integral is -1 to 1, and then our cs is x cubed plus 1 ds. So how to integrate? So first step to integrate is first we copy the expression. So what is our expression? Our expression is s ds. So we copy it. We copy s. And then second step, we add 1 to our powers. So what is our power? Our power is 3. So we add 1. So it will become power of 4. And then third step is divided with the news power. Our news power is 4. And then that adds 4 powers of 4 divided by 4. And then the last step is if the number doesn't have any variable, so we add it. So our function is ds. So we add s to the number 1. So it will become x power of 4 divided by 4 plus s. And then negative. Our limit integral is -1 to 1. And then we substitute our limit integral to our integration. So bracket x power of 4 divided by 4 plus 1 and minus with -1 power of 4 divided by 4 plus -1, and then will become 5 over 4 minus with -3/4, and then negative, so we will get positive 5/4 plus 3/4, and then we can get 8/4. Then our answer is 2 unit squared, y squared, because it is area. If it is volume, so we can change it to unit cube. And now we can proceed to my friend Afwan.
Okay. For my job is about the volume. So the volume have two methods. One this method and two washer methods. So I use the washers methods. So the answer is find the volume of the solid produced when the region that bound by the curve of y equal 4 minus x to the power of 2 and the line y equal x plus 2 is revolved about x axis. So about this question, we will use the formula volume equal integrate a to b pi fx the power of 2 minus gx the power of 2 dx. So how we want to find fx and gx? So from the question, we can see from the above to below. So the first layer we have found is the curve layer. So that is the fx, and the second layer is the line, and that is the gx. So for this formula, we don't know about the x, and we can find it with y equal 4 minus x the power of 2. So y we can replace with x plus 2. So we will get x equal 1 and x equal -2. So how to solve it? We will replace it in the formula. The volume equal integrates -2 to 1 pi 4 minus x the power of 2 minus x plus 2 the power of 2. So pi we will remove to the outside, and we will solve the problems. 4 minus x the power of 2, so it can get x the power of 4 minus 8x the power of 2 plus 16 minus x the power of 2 plus 4x plus 4. And then we will minus it, and we'll get x minus of 4 minus 9x the power of 2 minus 4x plus 12. Then we can integrate it with x the power of 4. We can plus 1 for the power. We can get x the power of 5 per the new power is 5. Then minus 3x the power of 3. It is because x minus of 2 plus 1 it can get 3, and per 3 and 9 divide by 3, and it get 3x the power of 3. And then for x the power of 1 plus 1, and it get x the power of 2 per 2, and 4 divided by 2, it can get 2x the power of 2, and 12 get 12 the x. Then we can integrate it. We can replace it with 1 and -2, and the answer we will get 36 per 5 minus -72 per 5. As we know that negative found negative, and it can get the charge of positive. So 36 per 5 plus 72 per 5 and get 108 per 5. Then the unit is pi unit cube.
Okay, so after listening for the both of our member group about the application of integration, so conclusion for today is that it is important for understanding a wide range of real-world problems, including a range of contexts in physics, and engineering is also significant when studying mathematics, which is real and complex analysis.
It is proven that we can settle many problems in real life by using a variety of methods in integration, such as this method, washer method, and cylindrical shell, which is even not stated in presentation, but these strategies are crucial.
We can get the volume or area of any graph calculating the area below the graph. That's why integration is commonly used in many types of fields of works.
Okay, as you can see, this is the reference that we use for our project in MAT138 subjects. We commonly use Google to search any info about the application of integration in our daily life. And the most important of our resource is from the textbook of Calculus 1, Science and Engineering from UITM Cawangan Pulau Pinang. So I think that's all from us. Hope you understand what about of application of integration in our life and even in calculus subject. Thank you for watching.